Okay, so let's give an example of a linear first order equation. So let's take the following: xy prime plus 4y equals to 6x squared. And let's put an initial condition: y of 1 equals to 2. So let's solve this initial value problem. So that's a linear first order, but before starting, let's put in a standard form. So standard form implies having only a y prime here, so divide by x all the way. So standard form will be y prime plus 4 over x times y equals to 6x. So that's a standard form because it looks like y prime plus a of x times y equals to b of x. So in this case, small a of x equals to 4 over x. Then there's a standard trajectory from small a of x to capital A of x, which will be antiderivative. Big A of x equals to integral of 4 over x dx, and this will be 4 logarithm of x. Then the integrating factor e the power big A of x will be e the power 4 logarithm of x, and this will be x to the power 4 according to the general formula e to the power 3 log x. Good to keep it in mind, equals to x to the power 3. So the integrating factor is x to the power 4. So multiply the linear first order equation in standard form, which is this one, by the integrating factor. And it will lead to a differential equation. It's pretty straightforward to solve. So what we get? X to the power 4y prime plus 4x cubed y equals to 6x to the power 5, because x to the power 4 is x to the power 5. The whole point of the integrating factor is that the left-hand side is an easy derivative of a very simple term. And like we discussed, this can be obtained by simply imagining that this prime disappears and see what's left. X to the power 4 times y. So this whole left-hand side is x to the power 4 times y, everything prime, equals to 6x to the power 5. Now, the only thing which remains to be done is to integrate left and right, and this will imply x to the power 4 times y equals to integral of 6x to the power 5 dx is x to the power 6 plus c. That's the first time technically we want to put a c. And this will imply y equals to x squared plus c over x to the power 4. There's the general solution of the linear first order equation. Throw in the condition y of 1 equals to 2. So let's see. Set x equals to 1 and y equals to 2 here. So what do we get? 1 plus c equals 2. Therefore, c equals to 1. And finally, this implies the solution of the IVP is y equals to x squared plus 1 over x to the power 4. It's a very good example of linear first order differential equation. The next important type of differential equations in this section will be Bernoulli equation. Okay, so so much about linear first order. So Bernoulli equations will be reducible to linear first order. Let's take an example. Bernoulli equations. Our example will be the following. Let's find the general solution of the following Bernoulli equation. Y prime plus 2y equals to y to the power 5. So this is standard Bernoulli form. What's the standard Bernoulli form? Standard Bernoulli form is y prime plus p of x times y equals to q of x y to the power alpha, where alpha is not 0 or 1. We put this condition so that we don't really get a linear first order because we already know how to solve linear first order. It's a genuine non-linear equation. So in this case, the alpha from the general theory of Bernoulli equation is 5. What's the standard substitution for Bernoulli equation? Substitution is u equals to y to the power 1 minus alpha. In this case, y to the power 1 minus 5, which is y to the power minus 4. That's the Bernoulli substitution. But more important than Bernoulli substitution is the reverse substitution. The reverse substitution is y in terms of u. So far the substitution is u in terms of y. Now we want y in terms of u. So y equals to u to the power minus 1 over 4. Once we got the reverse substitution, on the spot write down the equality of derivatives. This implies y prime equals to minus 1 over 4 u to the power minus 5 over 4 times u prime. And then replace it in the standard form. So replace this one and this one. So y and y prime, replace them in the, so this y will be replaced here, and this y prime will be replaced here. So let's see what we get. Y prime is minus 1 over 4 u to the power minus 5 over 4 times u prime, that's y prime, plus 2y, so 2 u to the power minus 1 over 4, y prime plus 2y equals to y to the power 5, that's y to the power 5 is u to the minus 5 over 4. Now, this is kind of an ugly looking equation, but to make it look nicer, we have to clean up from around u prime. So, what should we do to clean up from around u prime? Multiply by minus 4 u to the power 5 over 4. So, multiply by minus 4 u to the power 5 over 4. So, see what we get. U prime minus 8 u, because the power gain is u to the power 5 over 4 times u to the minus 1 over 4 is u to the power 4 over 4, which is u, equals to minus 4 u to the power minus 5, minus 4 u to the power 5 over 4 times u to the power minus 5 over 4 is just minus 4. So, by using this Bernoulli substitution, we transform the Bernoulli equation into a linear first order. Linear first order. This linear first order has small a of x equals to minus 8. What's next? Big A of x is minus 8x on the derivative, and the integrating factor e to the power big A of x is e to the minus 8x. So let's multiply this linear first order by the integrating factor left and right. So what we get? E to the minus 8x times u prime minus 8 e to the minus 8x times u equals to minus 4 e to the minus 8x. On the left, we have a derivative of e to the minus 8x times u. So e to the power minus 8x times u, everything prime, equals to minus 4 e to the minus 8x. Now integrate left and right, we'll get e to the minus 8x times u equals to integral of minus 4 e to the minus 8x dx plus c. So what will be this one? It'll be 1/2 e to the minus 8x plus c. So e to the minus 8x times u equals to 1/2 e to the minus 8x plus c. So, okay, so let's try to solve for u. So multiply by e to the power 8x left and right. So this implies u equals to e to the power 8x times this must be 1 over 2 e to the minus 8x plus c. And if we open the parentheses, we'll get 1/2 plus c e to the power 8x. So that's to solve for u. U is a substituted form. Let's go back. So if u equals to 1/2 plus c e to the power 8x, let's go back. Let me read this stuff. Let's go back to y. What is y? Look at this. Let's try to only come back to this. Y equals to u to the power minus 1 over 4. We got u. So from this one and the inverse substitution, we get y equals to this quantity to the power minus 1 over 4. To the power minus 1 over 4 is 1 over the full root. It's 1 over the fourth root of 1/2 plus c e to the power 8x. So that's the general solution of the Bernoulli equation written in the beginning. So let me write down again the Bernoulli equation so that you know the beginning and the end. The equation was y prime plus 2y equals to y to the power 5. General solution will be what we got.